Okay, this is target 2D, understanding linear functions. This is going to be page 262, chapter 4.7 in your books if you want to follow along. Okay, so the objective is to be able to use function notation and solve functions when given a specific domain. Vocabulary, a lot of this will be familiar. Function notation, it's a way to name a function that is defined by an equation. In other words, the f of x equals mx plus b, which should be familiar to you because it looks a lot like this. Okay, and that's slope-intercept form. And I will get into naming that later, okay, just as a reminder. Family of functions is a group of functions with similar characteristics, and the parent linear function is the most basic linear function in a family of linear equations. In other words, f of x equals x, or y equals x, you might be familiar with. And if you were to graph this, pardon my, crummy little graph there, it would basically look like that. When x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2. Okay, so on and so forth. You get the idea. All graphs are basic modifications of this. Okay, so as a refresher, for the function, the f of x equals 3x plus 1, find the value of x so that the f of x equals 10. Notice I didn't say x equals 10, but the f of x equals 10. What does that mean? In this function, x is a domain given, which you understand that this is your domain right here, right? Okay. But since we are told that the f of x equals 10, the range is 10, and we have to solve this for x. So this is the same thing as far as solving it goes as saying y, and y can also be range, it can be output, it can be the dependent variable. Okay, so you get the idea. In other words, we're solving this for x this time. We're not solving for this part. So basically, we're just replacing f of x with 10. So you have 10 equals 3x minus, or 3x plus 1, and we minus 1 from both sides to get 9 equals 3x, and then you divide both sides by 3 to get x equals 3. So you could then say that the f of x equals 10 when x equals 3. Okay, so that's how you would answer that question. Now let's apply this to real life. Say that we're comparing the cost of 2 DJs to work a party we're having. One DJ costs $50 plus $25 per hour. The other costs $25 plus $45 per hour. Now write out the two functions and create a graph that models the two functions to see which is going to suit our needs best. So we have these two equations that we come up with. All right, now how did I get these? Right, this is kind of like you've done this before. The only difference is we don't have this. Before you did. Okay, this 50 is this 50 up here. Okay, it's a constant. It doesn't say that that's $50 per anything. There's no variable attached to it. Okay, that per comes in over here. Remember, that per is a good way to tell that you have a variable. So it's $25 per hour. So we would say 25x, where x is the number of hours the DJ is needed. Okay. And then down here, you've got this equation, this part here. Okay, the 25 is your constant again, $45 per hour. This is a good thing. Words to look for your variable. Okay. We're going to call this variable words. That's not a very technical term of using, but per, each, those kinds of things. Look for those words, and that'll help you figure out which one gets the variable. So we've got these two equations. The f of x equals 25x plus 50, and the f of x equals 45x plus 25. Now, let's say that I wanted to figure out, okay, well, which one's going to be cheaper for a certain amount of hours? Well, I could say, well, let me just put in the number of hours I need them for and see which one, comes out to be higher or lower. Or you could take these two equations and graph them. Okay, think of slope-intercept form when you do this. Y equals mx plus b. Okay, the m is your slope. Slope is rise over run. Okay, so that means you go up or down, and then run, I always say go to the right. Okay, so if it's negative, you go down. If it's positive, you go up, and then go right. You can do it a different way, but just for the sake of continuity, for the sake of consistency, let's just say if it's positive, you go up. So we'll say positive slope, go up, negative slope, go down, and then always go right. And then B, this number here, is going to be the y-intercept, where your line crosses the y-axis. All right, so here's basically what we're looking at. How do you know which one's which? Well, this is 25x plus 50. So let's see where there's a 50 that crosses the y-axis, right there. And that 25x is our slope. Remember, we can write 25x as 25 over 1x. So since it's positive, I would go up 25 and then over 1. Notice the difference in the units. Each square, basically, each numbered tick mark is 50. Each, just hash mark that's by itself is 25. Whereas one whole, line over is 1 hour. So just be aware of the difference in the graphs or the difference in the values of the axes. So that crosses it 50 right there. And then our slope is 25 up and then right 1. This one starts at 25 and its slope is 45 up and over 1. So you could do 45 up and over 1, and that would be right about there. And the other one's right about there. So if you only needed him for an hour, this DJ is cheaper. DJ number 2, which matches up with this one right here. But once you go beyond that hour, the first DJ is cheaper. Okay? So graph's an easy way of determining that just by looking at it. All right, so what does graphing functions tell you? Okay? Again, if you only need them for an hour, the second DJ was cheaper. Okay? Could you tell this without graphing? Yes. You could just plug in 1 hour if that's what you needed it for and solve for the f of x when x equals 1. Is it possible for the domain of this function to be -1? No. There are certain graphs that you can't go into the negative numbers with. So we would say in this case, x is going to be greater than 0. Okay, x can't be 0 because you're not going to have the DJ come to the house and leave. He's still going to cost you $50. So we're going to say x is greater than 0 would be the domain for this. Okay, the range, that's of course, variable, but for x, we can just say x is greater than 0. All right, so now remember, when you say the f of x equals and y equals, they're basically the same thing with regards to how you solve the problems. Okay, there are some differences between the two, but not in how you approach solving these types of problems. And also understand that slope-intercept form, it's not just a name. The non-variable parts of the equation correlate with the name slope-intercept, where m is your slope, b is your y-intercept. So eventually you're going to get to the point where you're going to see this, and you're going to say, I know right away that's my slope, and that's my y-intercept. So I can look at just this last part, if it's in that form, and say, I know exactly where this graph should cross the y-axis. Okay? So that's it for today. Be ready for a video quiz first thing tomorrow. And hopefully we all have a good grasp on this. Have a good day.